Okay, so yesterday we talked about exponents. The top of this page is the exact exponent rules that we put in our graphic organizer. It's just written with A's and B's instead of just X's as the situation. So I like this part. Remember, order of operations matters. I also really like the second bullet right here where it shows if you have a number to a power and a different number to a power, you're basically distributing that power through so that you multiply the two powers together. And then if you have a fraction that's to a power, that fraction still splits apart, but the power goes to both of the numbers. And so this is just kind of a cool way of seeing a little bit different exponent rules. So we're going to start on 1A. When we simplify, we could go two different ways with this one. Because it's numbers, we could actually multiply inside there first. So 2 times 3 would make 6. So this would be 6 squared, which is 36. So that's one way we could do it. Or we could distribute the squared through and make it 2 squared times 3 squared. 2 squared would be 4. 3 squared is 9. And so 4 times 9 is 36. So it doesn't matter in this specific scenario which order you go in. This one actually gets you there faster if you multiply first and then go from there. Let's look at B though. So this is the reason I showed you the other way. These have variables. So can we actually multiply X and Y together? No. We can't simplify inside first. So see how these are, everything in the parentheses is raised to the power of 3. So we could rewrite this as X, and then we would have 2 times 3, so it would be X to the 6th. And then we would write times Y, or just the Y right next to it. And we would do 5 times 3, because that's the power rule, would be 15. And that would be our final answer. If it helps you, I could say 2 times 3 and Y 5 times 3. And then that's why we got X to the 6th, Y to the 15th, because the power rule says we multiply. Okay. So then when we look at C, we have a combination now. We have some coefficients and we have some variables. So I'll rewrite this. The weird part about this is the coefficients get the cube as well. So this would be like saying -4 cubed X squared times 3 times 3 cubed Y 3 times 3. So I'm writing out each and every step so you kind of see where I'm getting that. So that means everything inside of there gets the cube. So random side note, I could have done -4 times 3 first and gotten -12 and then just done -12 to the 3rd power. But either way you do it, we'd get the same answer. It would be faster and easier if we had multiplied first. So -4 to the 3rd power. So it would be -4 times -4 times -4. Okay, so one thing you could do in your calculator is do parentheses, -4, close parentheses, and then you use the caret key and then a 3. So we get -64. And then X 2 times 3 is 6. Then 3 to the 3rd power is 3 times 3 times 3, which is 27. And then it would be Y, and then 3 times 3 is 9. So this is not all the way simplified because I still have coefficients that I could multiply. So -64 times 27, that's supposed to be a times dot, not like a decimal. So -64 times 27 is going to be x to the 6, y to the 9. So again, I'll just bring up that if we had done negative 12 cubed first, we would have gone straight to this number. Now, it needs to be mentioned because later we're going to go somewhere else, but all of these numbers inside the parentheses are being multiplied. That's why we're doing it this way. Okay. Another way you could look at this is writing this same thing out 3 times and multiplying it together. So on D, oh, sorry. On D, I want you to see it's a fraction. A lot of us, we don't like fractions, so we try to turn everything into decimals, but I would strongly suggest you not do that because in a minute, we're going to be dealing with variables and we can't turn that into decimals. So I want you to see when you have a fraction in parentheses raised to an exponent, it's like saying negative 3 squared over 4 squared. Both the numerator and the denominator get that exponent. So then we're just going to simplify negative 3 squared. So it would be like in parentheses in our calculator, negative 3 squared would be just positive 9. And then 4 squared is 16. And if we could simplify, we would simplify. Like if we could reduce, we would reduce, but we can't reduce that. So feel pretty good about that one. So we'll go to E now, and you'll notice now we're dealing with some variables. So we would do a to the 4th to the 2nd power. So do you want me to write it as multiplying so you see what happened, or can we just multiply? Just multiply. So 4 times 2 is 8. So now each power, even on the bottom, we're going to multiply by 2 because it's the power rule. So it would be a to the 2 times 2 is 4. And b, negative 2 times 2 is negative 4. Now, we've gotten rid of the power, but now we have to simplify using the rules that we've learned. So I have same bases, a's right here. So when I'm dividing by the same base, and they have the same base, I subtract my exponents. So 8 minus 4 is 4. So it'd be A4, and it's on top. And right now I have A4 with B to the negative 4 on bottom. Is it okay to have a negative exponent? No, that's not like simplified. It's not proper. So what we learned yesterday is when we have a negative exponent, then the entire thing gets to move to the other side of the fraction bar and the exponent turns positive. So this is going to actually move up top and the exponent would be positive. So our final answer would be a to the 4th, b to the 4th. Bless you. Yeah, so when we have a negative exponent, it flips to the other side of the fraction bar. So since it's on the bottom right now, it's going to flip and go to the top, to the numerator, and then the exponent will change signs. If you want to know the why behind it, here's why. We could do a to the 4th over 1 over b to the 4th, and that's what we did yesterday. But this says a to the 4th divided by 1 over b to the 4th. Dividing fractions is easy as pie. You flip the second and multiply. So it would actually become a to the 4th times b to the 4th over 1. And then that's why it ends up being a to the 4th, b to the 4th. So this is just the why behind. So instead of doing all of those steps, I just know that dividing by 1 over something is basically like multiplying by the reciprocal. Does that make sense? So there we go. Too much explanation for some, but some of you like to see that why. Oh, gotcha. Okay. So good now. On F, we have a fraction, and it has the power rule as well. So remember, when I have an actual coefficient, the coefficient gets the power also. So just for our notes, we'll go 2 to the third power, x to the 2 times 3 is 6, over the coefficient of the bottom also gets it, so 3 to the third power, and then the power rule says 3 times 3 is 9. And then y to the 2 times 3 is 6. We're going to clean this up a little bit. We're going to actually find 2 to the third power is 8, x to the 6th. 3 to the third power is 27, x to the 9, y to the 6. So I'm going to first look at our coefficients and see if we can reduce those, and the answer is no. Then I look and I check, do I have any same bases? And yes, I have x's and they're being divided. So I would get 6 minus 9 is negative 3. So I'm running out of room over here, so I'm going to go down here. It would be 8x to the negative 3 over 27y to the 6. It's not okay to have a negative exponent, but the negative exponent only belongs to the x, not to the 8. Okay? So in order to get rid of the negative exponent, this x gets to flip to the other side of the fraction bar. So my final answer is going to be 8 over 27. So here's the deal. Alphabetical order matters, right? So the x gets to come before the y, like that. Pretty cool. All right, very bottom. Examine problem C and problem D. So we're looking at these middle problems. What occurs with negative coefficients when powers are distributed into the problem? Okay, so what we're talking about, in problem C, we had like negative 4 to the third power. But then in problem D, we had negative 3 squared. So what we're trying to get to is, if I have a negative number to a third power, the answer ended up being a negative number. If I have a negative to a even power, the answer ends up being positive. So we're going to write that. If the power or exponent, you could call it either word, is even, then the final answer is going to be positive. If the power or exponent is odd, the final answer would have negative. And that's talking about like coefficients, like actual numbers. And the reason is because of integer rules. Because if you have a negative times a negative, it makes a positive. But if you have a negative times another negative, this would make positive, and then the third one, positive times negative, makes negative. So that's just for you to see, which you guys probably saw that already. Okay, so that's just kind of using the rules from yesterday to a little further extreme. Now we're going to go into some like word problems or situations. So we're all good? Not yet. All right, so the next one looks like a scary word problem, but when we read it, it's actually not so scary. The size of a genetically mutated bacterium is given by the expression 2p to the negative 3, where p represents the length of the original bacterium in picas. Write the expression in simplified form without a negative exponent. So all of this really just means, hey, we're going to write 2p to the negative 3 in simplified form. And it's not simplified if it has a negative exponent. So question, that negative 3, who does that belong to? The p. So the 2 doesn't have a negative exponent. It actually has an exponent of 1. So the 2 gets to stay up top. And you have to remember, everything is always like over 1, even though we don't always write it over 1. So the p to the third, in order to make it a positive exponent, we're going to put it to the other side of the fraction bar. So it'll be over p to the third, and it's now a positive exponent. And so this is our answer in simplified form. So even though it was all like talking all sciencey and scary, not really scary. Okay?
So scary.
Not really. Yes. Okay. So this says, what value of A will make the statement below true? So they gave us the final answer. They did not give us this exponent right there. Okay? So, to be really honest with you, do any of the numbers actually matter to us? So, like, we know the final answer would be 27, and you could do it. What's 12 to the third power? So, will you type in your calculator 12 to the third power? And then, is that what you got? Divided by, what's 4 to the third power?
No. I don't know. 64.
What's 1728 divided by 64? 27. So we already know this part and this part. So those coefficients don't really matter to us. What we need to know is the exponent of x. So first what we're going to do is we're going to distribute the power rule. So on this left side, it would become x to the 3 times a over x to the 5 times 3 is 15 equals x to the 12th. And when we divide and we have the same base, what do we do to our exponents? We subtract them, right? So we know that 3a minus 15 is going to equal 12. And now it's just a simple equation. So we add 15 to both sides. So we get 3a equals 27. We would divide by 3, and we would get a is 9. So this is like knowing the power rules and all of the exponent rules instead of just like constantly looking back and forth at them. Like you have to know them enough to be able to put them into place like this. Okay. One more example for you, and there will be one like this on our homework. The figure below shows a rectangle. Write an expression for the area of a rectangle. So to find the area, you do base times height or length times width, however you want to write it. So we know it's going to be this side times this side, right? So I'm going to put 3x to the 4th y squared times 2x to the 3rd y squared. Order of operations says I had to take care of this power first. So I know I have to distribute that to everything inside because it's a monomial. It's all being multiplied. So 3 squared is 9. X to the 4th to the 2nd power would be x to the 8th. I'm confused because my y has nothing right here. So it's a 1 times 2 is 2. Then I'm just bringing down the rest for a second. Now I'm just multiplying monomials at this point. So I'm going to start with 9 times 2 is 18. Then I'm going to look at same basis. So I have x to the 8th times x to the 3rd. So I know it's going to have x. What do I do to my exponents when I'm just multiplying? Add them. So 8 plus 3 is 11. And then same base y and y. So 2 plus 2 is 4. And that is the expression that represents the area of that rectangle.